Calculate the number of moles of sodium in 34.5 grams of sodium metal. The molar mass of sodium is 23 grams per mole. Therefore, there are 1.5 moles of sodium in 34.5 grams of the metal. Calculate the number of grams of copper in 0.2 moles of copper. The molar mass of copper is 63.5 grams per mole. Therefore, 12.7 grams of copper contain 0.2 moles of the substance. Calculate the number of atoms of phosphorus in 77.5 grams of the substance. The molar mass of phosphorus is 31 grams per mole, so there are 2.5 moles of phosphorus in 77.5 grams of it. 1 mole of a substance contains 6 times 10 to the 23 atoms, molecules, or particles. Therefore, there are 1.5 times 10 to the 24 atoms in 2.5 moles of phosphorus. Calculate the number of moles in 32 grams of methane. The molar mass of methane is 16 grams per mole, so there are 2 moles in 32 grams of methane. Calculate the number of hydrogen atoms present in 40 grams of urea. The molar mass of urea is 60 grams per mole, so there are 0.67 moles in 40 grams of urea. 1 molecule of urea contains 4 hydrogen atoms, and 1 mole contains 6 times 10 to the 23 atoms. So 0.67 moles of urea contains 0.67 times 4 times 6 times 10 to the 23 atoms of hydrogen, which equals 1.6 times 10 to the 24 hydrogen atoms. To determine the volume occupied by 6.3 grams of carbon monoxide at SDP, we first need to calculate the number of moles contained in these 6.3 grams. The molar mass of carbon monoxide is 28 grams per mole, so we have 0.225 moles of the substance. Since 1 mole of gas occupies 22.4 cubic decimeters at SDP, 0.225 moles of gas occupies 0.225 times 22.4, or 5.04 cubic decimeters. Before we can determine what volume of sulfur dioxide is formed at SDP from burning 16 grams of sulfur, we first need to write down a balanced chemical equation. Next, calculate the number of moles contained in 16 grams of sulfur. Now, use mole ratio to determine how many moles of sulfur dioxide are formed from burning 16 grams of sulfur. Since 1 mole of sulfur reacts with 1 mole of oxygen gas to produce 1 mole of sulfur dioxide, it follows that 0.5 moles of sulfur dioxide were formed from burning 16 grams of sulfur. And now that we know how many moles of sulfur dioxide we have at SDP from this reaction, we can calculate the volume of gas occupied by sulfur dioxide, which is 11.2 cubic decimeters. Note that we need to balance the chemical equation before we can start, so 2 moles of potassium chlorate decomposes to form 2 moles of potassium chloride and 3 moles of oxygen. We then proceed as per usual, by calculating the number of moles of potassium chlorate that decomposed from 24.5 grams of the substance, which is 0.2 moles. And now we use mole ratio to determine the number of moles of oxygen gas formed from this decomposition, which is 0.3 moles. And now that we have the number of moles of oxygen formed at SDP, we can calculate the volume occupied by the gas, which is 6.72 cubic decimeters.